Right. So to study Z3 more. So for my course at uni, I need to solve an exercise which I think is an advanced knapsack problem. So I thought I would first try and solve the classic knapsack problem using Z3. Uh, I thought I would do it live, like record. I struggle. There is okay. So I gathered a couple resources. I have this tutorial thing in the back that I showed in the other video. And I have an example here that's apparently also a knapsack problem, but it's a little bit different, I think, because you kind of have like infinite items, whilst the so I looked up the definition of a knapsack problem, and I think I found an example on the For Geeks website where they explain it like you have a bag with a maximum capacity, and then you have a set of items. Every item has a weight and a profit, and then you need to figure out what is the best subset of items to take with you that still fits within your bag, but generates the maximum amount of profit. So I generated a random thing that I mean, a random problem statement. I just came up with it myself, so I hope it kind of makes sense. I think, oh yeah, I should have written what I think. Wait, I think I still have the original file. Yeah. So I thought, okay, so, yeah. Each item is a pair of weight and then profit. Maybe I should, uh, like this. I'll write like that. Okay. And then I have some like a little Z3 boilerplate hello world, I guess. So that I can get started without needing to look up too many things. Those knapsack problems are optimization problems. So we use the optimize solver from Z3. I don't really know all the types yet. Stuff. And I also think we're not gonna do int here because I copied the int from yeah. So I copied the int idea from the popsicles. But I think we're gonna have to do so every item. Someone being annoying outside. I hope you can't hear that. So I think here we have 5 items. I think I'm just gonna make 5 booleans. Because in this example, it's like a store with kind of like infinite popsicles. But in our example, you can only take each item once. So I think it's kind of like an integer that can not go over 1. So you might as well encode it as a boolean, right? So we have, I think we're going to have, first introduce 5 variables where every one is a bool. And every bool means like we're taking this item with us. Yeah, so maybe let's try and do that first. Kind of daunting, to be honest. This is harder than I thought. Kind of scary. Maybe we can do it like in one go, just like they do here. Instead of ints, we say bools. Try that. And then, oh yeah. Okay, so let's say item 1, item 2, 3, 4, 5. 5 is bulls. Item 1. 2, 3, 4, 5. 4, 5, like that. And then I don't know, how do we like encode the weight stuff now? Let's see. Because now we kind of need to have to do if statements and stuff, right? Let's see if they have Boolean logic. Because now we kind of need a function from our items to our weight. I mean, okay, what do we have? We have a, for example, if we take, we need to kind of introduce a total weight function or something. I'm thinking. Is like, maybe we do have to do it like numbers, but they can just never go over 1, and then we can just encode the whole weight, like for example item 1 times 7 plus item 2 times 5 and so on equals total weight, and then we can say total weight is less than 21. Yeah, maybe I'm gonna do it like that. Yeah, so this does need to be int, right? Like here. Oh yeah, so it's almost like the popsicles. I start seeing the similarity now. Oh man, I don't have my clipboard set up properly in Vim. Okay, let's do total weight is int total weight, and then total profit. Profit. Okay. And now, how do we do that stuff? Okay. Okay, yeah, I start seeing now how this sense. Oh, okay, so s dot add total weight is item 1 times. Okay, wait, maybe I'll copy this and make a little macro or something. Can be annoying. Oh. No, okay, wait. Okay. Oh no. Okay, and then 2, 3, 4, 5. Oh, and then every item has to be. Wait, I need to think about this plus item or something. That looks funny. Oh no, like this? Yeah, that looks right. Let's look at the pops. Yeah, okay. So we're almost copying obstacle thing, really. And then we need to do the same thing for profit, but we have those different numbers, right? So 1. So I'm copying from up here now. 1, 9, and 9, 1. Okay. Yeah. And then maybe we have to add that we can never take an item more than once. Wait, and okay. It can never be negative. That's also important. I think we should also add that, right? Oh, can't we just do? What is that? Oh, oh man, caps lock. Sorry. Now, I think this is definitely not going to work yet, because now it can maybe take one item twice. So I wonder how I can quickly. I could add like every item is greater than or equal to 0 and less than or equal to 1. The thing I still don't really get about D3 is the code is always so repetitive. Like there's probably a bunch of ways of shortening. I haven't really figured that out yet. Like the way they do, I really visited the Sudoku. Okay, but I'm getting kind of off track. But like they do stuff like this. I don't have that figured out yet. But yeah, okay. That's for next time maybe. I'll just do it like in a dumb way right now, right? So let's see here. Oh, this is silly. I don't know what that. Let's maximize total profit. Then we still need to add item 1 less than or equal to 0. Maybe we can do it with the. Okay, I'm just gonna do it the dumb way. Sorry. Just for the video, quickly get things moving. Because if I start going off some trail that I don't understand yet, might take even longer, right? Okay, so we have 5 items that are okay, and then we do up, change this to that. Oh, wait, less than or equal to 1 and greater than or equal to 0. Yeah. Okay, so that might be everything. That's gonna work. Max capacity 21. Okay, let's see what it does. Opa. So it came up with 134. And wait, and what did it maximize? I'm kind of confused. Maximize total profit. Okay. So it came up with 134. I should have maybe solved this problem first. Maybe I'll pause the video real quick, solve the problem by like brute forcing it or something, and then come back and see if D3 solution was right. Okay. See you soon. Okay, so while attempting to brute force the solution, I looked back at my D3 code and I noticed something very strange. I forgot to put in the constraint that the total weight is less than or equal to 21. So I have no clue why Z3 did not just say, take everything with you. Makes no sense, right? I must have done something wrong, but I can't figure it out. Because if I run this, it says only take item 1, 3, and 4 and not 5 and 2. And it does do total weight kind of right. Like, how is that possible? I never used this factor. So strange, right? Let's try adding this and seeing what it does. I don't understand at all what is happening right now. Because what I would have predicted is that Z3 would have now just said, make all items 1. Right? Because then the total profit is... Oh, wait. What? What happened here? Okay. I introduced the same variable twice. That's weird. Okay. It's odd that it didn't even report an error. Because not here I did something like senseless. This is all very odd. As add total weight smaller than or equal to 21. See what it does now. Okay, it does something different. Now it says take 3, 4, and 2 with you. 3, 4, and 2. Total weight is 18. Total profit is 28. Okay, this makes more... I mean, yeah, last time it didn't even report whatever the profit was. So that makes sense. Okay, so I'm going to continue brute forcing it, which is happening on the left-hand side there. But I'm not going to add it to the video because it's kind of irrelevant. Okay, be right back. Okay, so I'm done brute forcing the problem. And it came up with the same solution. So I think I did it right. So yeah, that was an example of solving the basic Knapsack problem in D3. Thank you.